All right, everyone, welcome to Australia and New Zealand. I'm here in Sydney Harbor, not actually there, just my backdrop. This, again, and I say this almost for every region we've covered, this is one of my favorite regions in the world as well. And I was able to spend time there again on another study abroad program, and I would love to go back. So I'm going to share my screen and we'll get going. All right, so Australia, New Zealand, a very unique place. New Zealand was one of the last places on Earth that the Polynesians inhabited. And then Australia was really kind of forgotten. There was some contact maybe earlier of people know the Dutch kind of sailing past it, but it wasn't really till the late 1700s that it was, I guess, discovered and started to be settled by the British. And as we see on the top, we're going to have quite a bit of talk about the Aboriginal populations who came there about 60,000 years ago. And then on the bottom, we see the much more diverse group of people that live in Australia, as about 20 to 25% of their population was born somewhere else. So let's start out with our plate tectonics. So Australia is on the Indo-Australian plate, so it's on the same plate as India, but it's far away pretty much from most tectonic plate boundaries. New Zealand's going to be different because it sits right on one. And we can kind of talk about this in terms of how it began. We can see that we had Pangea several times over the last years. We had supercontinents that were joined together, then they move apart, and sometimes they come back. So this is one that shows the different countries and where they were during the Pangea. But between 300 and 200 million years ago, it started to break up. And you can see Australia down there is linked right in there with Antarctica, as well as Tibet and India. So about 225 million years ago, we kind of see Pangea breaking up. It continues 200 million years ago, but Australia was still actually connected to Antarctica. And then it started breaking apart by 150 million years ago. And then you can see the next one about 60 million years ago. And today, this is what we see in terms of our continents from tectonic plate movements. Now, Australia is an ancient continent. It has some of the oldest rocks in the world, upwards of 2.5 to 4.5 billion years old. And that's what you're going to see in the brown color on this map. Those are the oldest in the west. In the middle, the orange, that's more of 500 million to 25 or 2.5 billion years old. And then in the east, you have the youngest ones, which are, around 500 million years old. So all of this is really old rocks and an old continent. We'll come back to that in a moment, why that's important. So looking at the physical regions, and we're going to start with Australia, we have the Western Plateaus. And these are really ancient rocks, as I mentioned, but that means there's a lot of mineral wealth. And Australia has a lot of that. That's one of their main industries is mining. In the central, you can see the Simpson Desert and those rivers in the middle is an old sea. So it's more sedimentary. And they call it the Great Artesian Basin. And that means it has a lot of aquifers and groundwater underneath. And so this is an area for a lot of farming and cattle ranching. It's a lowland that's been filled in, and you can see the rivers coming up here. They actually are exotic rivers, which means they don't make it to the ocean. They make it to this lake. And then you have other rivers that make it out. And the Murray River is a very famous one for cattle ranching as well as agriculture. And then you have the Eastern Highlands, the Great Dividing Range. They're not super high in terms of elevation, but they do get high enough, and especially in the southern part where they actually get snow, as we'll see coming up. And then you have your coastal plains. Now, almost most of the population in Australia lives along the coast. The interior is very dry, and so you don't see a lot of settlements there. So here's a picture of the Great Dividing Range having snow. And Australia is also known for having really good snowboarders. And so they do have ski resorts in that southern section of the Great Dividing Range. But the interior is much like this. You have plateaus and you have this red earth and very dry. Much of it is desert or steppe. And this is Uluru Rock, which is very sacred to the Aboriginal populations. It's right in the middle of Australia. and a very famous tourist site, but also sacred to, again, like I said, the Aboriginal populations. Now, as we mentioned, Australia is very stable geologically. It doesn't have any fault lines really very close to it. So very slight risk of earthquakes, but not much. And you can see down here their highest peak in the Australian Alps, which is part of the Great Dividing Range, is only 7,300 feet in elevation. And in the middle, you can see Uluru Rock, or Ayers Rock, as some people call it. But this old age means it's weathered away a lot. So it's considered the flattest continent, but has a lot of mineral wealth, however, relatively poor soils. Now, that is the exceptions are along the coastal plains as well as in the Artesian Basin along the Darling and Murray River, where they grow a lot of wheat and cattle ranching. But otherwise, much of it is very poor soils. And again, this just shows how Australia itself is far away from many plates, so it's really pretty stable. New Zealand down here, though, is another case. It lies right on a fault line. So here's New Zealand, kind of an opaque view. And on the right side, you can see a physical map of it. And you see there's a subduction zone that's going on the North Island, and that creates volcanoes and earthquakes. And in the southern island, that fault line runs right through it. And so the southern part gets lots of earthquakes. And recently there's one in Christchurch a few years ago that was quite devastating. But the north, of course, has volcanic mountains. The south has just really extremely large mountains. And we're going to take a look at that here in a moment. I traveled around the entire South Island, and my wife looked at it and she's like, this looks like Scotland on steroids. It was extremely impressive. So this is the volcano on the North Island. And we're going to come back to that here in a moment because we're going to talk about climate and climate change. So in climate, so most of New Zealand, I don't have it on this one, but most of New Zealand is marine west coast climates and highland climates. But for Australia itself, it's the driest continent. This BWH, that's all desert. You can see that takes up much of the country. The BSH is steppe climates, and you can see that takes up pretty much a lot more of that of the continent. So desert and steppe, very dry. In the north, though, you do have tropical savanna and a small monsoon if you get up near Cairns in the north. But in the north, you see the AW, which is that tropical savanna, which means that it has a wet season and dry season. But still pretty wet. And then the east coast and the south coast, we have more mid-latitude climates. So the north is CFA, humid subtropical. That's very similar to like we'd see like in Georgia, the southeast of the US or Florida. And then when you get down by Sydney, down to Melbourne, we have the CFB climate, which is a marine west coast climate. So we can think of a little bit more like San Francisco. And then the CS climates on the south around the cities of Adelaide, which is by this thing called Spencer. That's Adelaide is right there. And Perth, we have Mediterranean climates that are very similar to California. And this is the area, the main wine region for them as well, based on the fact that it's a Mediterranean climate. And that's where wine grapes grow the best. Now, in terms of climate change, a big problem that we're having when we talk about New Zealand, especially the South Island, they have a lot of glaciers. And their highest peaks are around 12, 13,000 feet, but they're pretty far south. And so they get a lot of snowfall, and they also have glaciers, but they're retreating. And I'm going to go ahead and stop sharing this and jump to a different share. If I can make this work correctly. So bear with me for just a moment. So hopefully you guys can see this. I'll check it on it later. But we went to New Zealand and did a trip around the South Island, and I was really excited to go see a glacier. There's a famous one, the Franz Josef Glacier. And there was a trail that you could hike to, and you can go to the terminus of the actual glacier. But we hiked to the end of that trail, and you couldn't see anything. There's a little blip way in the back because it's been retreating, and there's evidence seeing that it's been retreating for quite a long time, since the 1950s onwards. So I was kind of sad. So my wife said, let's go across the street. And she got me a helicopter trip to go look at the glaciers because we had to do that. We couldn't hike to them. And so as we're flying up, and here you can see a glacier on the top of this rock. That's actually a house. It's a ranger station. And here, then you can eventually see the glaciers themselves. Sorry, that's just my wife and I on top of the glacier. We got to land and sit on it. Here's the picture from the helicopter. We have the blade in there. And here's my wife sitting on the glacier. And if you go to the next slide, you'll see what it looks like where it drops off. You can see it sloping down. And that's where you're going if anything bad happened. So I just wanted to share a little bit of that. I also have some videos, but I don't think I want to bore you with everything at this point. But I was really sad, like I said, to go to the glacier and see that I couldn't find it. And then we actually had to take a helicopter up to actually see the actual glaciers. Another impact on climate change is intensified wildfires, just like we see here in California. You have some similar climates and whatnot, a lot of eucalyptus that burns very easily, and their wildfires have become very intense. And again, like we see in California. The last group, I think it was 2 years ago, that went to Australia during our winter quarter, but that's their summer. There was an island that we go to called Kangaroo Island, and it has a lot of unique wildlife, but the entire island basically burned down, and the students were being stuck inside their dorms because of the air quality. Now, in terms of biogeography, that's a very unique thing about Australia and New Zealand, is that they have very unique species because they've been isolated for so long from other continents that they've developed in different ways. So over geologic time, and that's millions of years, we've seen the wildlife evolve and change. And there's a thing called the Wallace Line, and that divides Southeast Asia from Australia, and it kind of runs right here, right through Indonesia. And so the different types of fauna are on different sides of this line, and they're very unique. And so that separates them from Australian and Oriental fauna. And you can see again, here's the Wallace Line. And this led to the categorization of wildlife realms around the world by identifying, because of this change, just right across that line, you have a totally different, unique set of species. So the types of mammals in Australia are very unique. So talking about mammals, we can have placentals. These are the ones where you have the embryo develops in the uterus. It's like humans, like you have a baby type thing. There's very few of those in Australia. The dingo is one of those. And the dingo is a type of wild dog. It was brought over by the Aboriginals perhaps 60,000 years ago. But it was introduced species. Marsupials are what are really unique about Australia. And this is where you have an embryo that partially develops, and then it goes into a pouch. And we think about kangaroos. I'll have a picture of that coming up. Koalas, we'll talk about them in more detail coming up. They're not bears. They're actually marsupials, and they're more related to kangaroos than they are to anything like a bear. They mostly eat plants. Talk about that in a moment. And in the US, the one that we can see here in the US are the possums, are actually marsupials, but I'm not sure if there's any others, but I know that that possums are. So it's relatively unique to Australia. And then one that I really thought was crazy are the monotremes, and there's only two of them in the world, and they're in Australia. And these are mammals that lay eggs. The platypus is one example. And when the English came and they came back and told the people in England that, hey, look at this creature, they thought they made it up. It looked like a duck mixed with a beaver. But no, it's a platypus. And so they lay eggs. And then the echidna, spiny anteater, is one that I really like as well. But those are the only two monotremes. Here's a picture of an echidnas. Their feet on the back almost look like they're reversed. It's weird how they do that. But they're really cute. And you can see them on the side of the road. This is at an animal refuge, a wildlife center. Here's some dingoes at the same center. So again, they're generally wild dogs. Here I am feeding a kangaroo. And I was kind of surprised at how big they actually are. And that's not even the largest of them. And then this one is a picture of, I think it's a wallaby actually, which is a relative of the kangaroo. And down here in the pouch, you can see a joey. That's what they call the joeys. That's the baby kangaroo or wallaby, whichever one it is, inside the pocket or the pouch. Here's with my favorite koala, Roger. He did have a name, eating eucalyptus leaves. And here's just a picture of two other smaller koalas sitting in a tree. So a couple interesting facts about koalas. They're not bears, they're marsupials. They're related more to kangaroos or wombats as opposed to, they're not a bear. They're pretty much kind of isolated, but koala in the Aboriginal language means no water. They don't drink water. They can if they need to, but they don't. They get most of it from the leaves and the vegetation that they eat. They also eat almost exclusively eucalyptus leaves, which is toxic to most people, but they have some enzymes in their livers that allows them to eat those. Now let's move to reptiles. And this is one that's quite interesting in Australia. There's a lot of dangerous reptiles. They have 40 snake species, 12 of which are deadly. They have 32 venomous sea snakes. And the inland taipan, which is a picture down here on the right, is the most venomous in the world. And as I wrote up here, 50 times more deadly than a cobra. But apparently they're very shy, so you don't really have a whole lot of problems with them because they're really shy. And then we have things like the death adder, and that just, yeah, amongst many others. Here's a monitor lizard. From the tail to the nose, we're looking at 7 to 8 feet. You're going to see one of those in your movie, The Rabbit Proof Fence, where the girls capture a monitor lizard so they can eat for the Aboriginal populations. So again, very unique biodiversity, and it's a result of that long geological history, isolation, separation. And again, marsupials are probably the best example of this. And the monotremes. However, we also have exotic species that have been introduced from other parts of the world. And many of um, the local biodiversity has never, existed with these other types of exotic species. They've never developed any defenses. So a lot of the ground birds, because they didn't have really many ground predators, became exterminated because of that. And so anything that's been introduced creates a lot of problems for the local species. Here's some examples. Foxes were introduced. And of course, they hunted on a lot of the ground running birds and other species. Cats are one of the great introduced species all around the world. And then rabbits were brought in. Oops. I'll just put that up there. So rabbits were brought in, and you're going to see the rabbit-proof fence as one of your videos, where they decided that the rabbits were going out and breeding very rapidly, and they're eating up all of the vegetation that they wanted to use for their cattle ranching. So they put up a rabbit-proof fence, which is the longest fence in the world. I don't know exact length. I think it says it in the video, but it stretches upwards of 2,000 miles, and there's a couple of them to try to keep rabbits from one side out of the rangeland on the other side. It didn't work. Rabbits can get through fences pretty easily. So they introduced a virus from South America to control the population, to get it under control. And then I have this great video. We're not going to watch it in this class, but it's called Cane Toads, An Unnatural History. And on the top right, you can see one of these cane toads. They can become quite large. They were introduced from the Americas to take care of cane grubs in the sugarcane fields. Apparently, they didn't do that, but they went ahead and ate everything else, and they exploded in population. They can reproduce very rapidly, and there's no predators for them. They have on the back, you can see up here, they have these poison sacs, which causes a heart attack. And they can eject it. It can go up to like 3 feet if it gets jostled too much, or if an animal tries to bite it, then it gets injected into them and they end up dying. So they find like death adders, taipans, any type of creature that tries to bite one of these things ends up dying. So it's a big menace. They're trying to find some biological ways to get rid of them, but they've taken over much of the east coast and the northeast coast of Australia, and is a huge plague. If you get a chance, watch the documentary on cane toads. It's quite interesting. Now, animal extinctions, and that's a big problem when you have a unique biodiversity, is that there's a possibility of them becoming extinct. And introduced species is the main reason for this. So almost 40% of extinctions have been because of introduced species. Habitat alteration is another major one. Hunting is actually a smaller percent. And then 2% is other. I'm not sure what that means. Maybe just natural selection. Okay, so we're going to stop now. We just covered physical geography. And in our next one, we're going to talk about historical and population geography. And I'm going to try to throw a few videos in for you. Thank you.